Thank you to our hosts to give us the opportunity to present the work we conducted within the REMIX European project. It's aimed at analyzing how various pilots of multi-actor experimental networks manage these networks in the view to support the design of sustainable agricultural systems and more precisely crop mixtures. This analysis was mainly conducted by Salembier, with the involvement of many colleagues, most of them being those pilots of networks. Multi-actor experimental networks are increasingly presented as a promising approach to foster innovation toward sustainable farming systems. They play a central role in many innovation and design approaches, but their contribution to the design of agricultural innovations has never been analyzed. What is a multi-actor experimental network? It combines various experiments, including on-farm and on-station experiments, each one having its own logic, and its management involves various actors. Thus, our aim was to identify the characteristics of such networks and to understand how they contribute to the emergence of sustainable agricultural systems, depending on their management. We analyzed 11 networks spread across 10 European countries conducted during 3 years. Our study was based on the analysis of documents from these networks and interviews with the pilots. As first result, we identified 9 different contributions of experiments to support crop mixture design. For example, the second, find one best option or highlight contrasts among a diversity of crop mixtures. The third, highlight the conditions to reach certain effects with one crop mixture. Or the sixth, build on unexpected events to highlight new properties of the mixture under design. And we also highlight different ways to reach each contribution. Our second result focused on the way the pilots within each network manage the coexistence and the interactions between the various experiments implemented. For example, on the network in the Netherlands, several experiments conducted the same year, some on farms and other on stations, contributed to the design of wheat faba bean mixtures by different functions. First, on several experiments where various mixtures were assessed, the pilots fostered the involvement of various actors in the experiment, thus sharing their points of view on the experimented mixtures and influencing those to be kept the year after. Second, on one experiment comparing several cultivars, the pilot highlighted the cultivars of wheat and faba bean with the best performance in mixture for the local context, thus recommending to grow those ones. Third, confronting the behavior and performance of the wheat faba bean mixture across 3 experiments, the pilot was able to define more precisely the validity domain for growing this specific mixture. As a third result, and based on the previous ones, we identified 3 main strategies for managing the multi-actor experimental networks to support crop mixture design, based on the comparison of the 11 case studies. These strategies differ according to 2 axes. The x-axis describes who takes the control of most of the process of experiment and design, either research and development organizations or the farmers themselves. The y-axis describes the type of outcomes that are targeted and reached, either produce robust references to be spread or foster the emergence of new practices directly on farm. The blue strategy gathered networks in support of design conducted by research and development. At the opposite, the green strategy describes networks aiming to support on-farm design. And the orange strategy in between describes networks in which the design of crop mixtures is distributed among several actors. Thank you very much for your attention.